All right, so we are looking at composite functions. All right, this is a combination of two or more functions. All right. So, for example, let's say you have a function f of x equals 2x plus 3. All right. And we have another function, let's say g of x equals x minus or x plus 1. All right. So we have two functions here, f of x and g of x. So if we write the composite function like this, f, right, let's see here, we have f, then in brackets, g of x, right, f g of x, this is our composite function. So what this is telling us that in our function of x, right, in our function of x, we're going to replace the x variable with the function of g, right? In our function of f, right, in our function of f, where we have this x variable will be replaced with this g function. So we can write it like this: f g of x equals, right, 2 open bracket. So this x, we're replacing it with the function, with the g function. All right. So we're going to put x plus 1 here plus 3. All right. So as I said, in the function of f, our x variable will be replaced with our g function, and that's what has happened here. This 2x, this x here has been replaced with the g function, g of x here. That's why we have 2x plus 1 plus 3. So we can solve, we distribute the 2 times x, that is 2x, 2 times 1, that is 2, right, plus, then we have a plus 3 here. So fg of x equals 2x plus 5. All right. What if they told us to write the g f of x, right, g f of x? So what this is basically telling us that in our g function, our x variable, we're going to replace it with the f function. All right. So remember, g of x equals x plus 1. So this x, we're going to replace it with the f function. All right. So we're going to have 2x plus 1, 2x plus 3, right? 2x plus 3, right? Plus 1, right? So our x variable in our g function was replaced by the f function. All right. So 2x plus 3, we just open the brackets here. It's going to just remain as 2x plus 3 plus 1. And we're going to get 2x plus 4 as our composite function. We can factorize this further. The common factor here is 2. 2x divided by 2, that is x. 4 divided by 2, that is 2. And that is our answer, g f of x. Right, let's look at another example. So you can pause the video to write down these notes so as I prepare the next example. F of x equals x squared. All right, g of x equals x minus 3. All right, so we're going to start with the first one, f g of x. So what this is basically telling us that in our f function, we are going to replace our x variable with our g function. All right, that's what f of x, f g of x is telling us, that in our f function, we'll replace our x variable with our g function. So since f of x equals x squared, and then we want to find fg of x, so we're going to we'll replace the x with the g function, which is x minus 3. So we have x minus 3 squared. Right? We replaced our x variable with the g function. So let's do our tabulation. So x minus 3, since it's squared, so we have to put the brackets like this, and we expand the brackets. Right? X times x, that is x squared. X times negative 3, we get negative 3x. All right. Then we say negative 3 times x, we get negative 3x. Negative 3 times negative 3, we get positive 9. All right, so we're going to get x squared minus 6x plus 9. That is our composite function. X squared minus 6x plus 9. All right. Then we'll now look at g f of x, meaning in our g function, we replace our x variable with our f function. So we're going to have g f of x equals, so this x, we're going to replace it with our f function. So we have x squared minus 3. All right. And that is your answer, x squared minus 3.